Okay, good. All right, we're going to look at more application of right triangle trig classwork. Okay, so we've got 5 questions here. On the back, we've got 4 questions for your homework, very similar to what we've been doing before. I don't think I'm going to do all of these. I'm going to give you guys some to do in class and have you guys come up and check it in with me, because I want to see how you're doing with these. But let's look at number 1. Number 1 is a rhombus, which ABCD with side lengths 3. Diagonals AC and BD meet at point E. If the measure of diagonal of the angle DAB is 46, find the length of EB. Who's confused? Yeah, that was a weird whole thing. So let's draw it. I'm going to draw it nice and big on my piece of paper right here. We know what a rhombus looks like, right? Okay, that looks more like a parallelogram, but we'll pretend it's drawn perfectly and all the sides are equal length. All right. It says the sides are 3, so all 4 sides are 3. Okay, and we've got triangle A, B, C, D. So we're going to name all these little endpoints those different letters. A to C. Yep. A to C. And B to D. Oop, this is D. B to D meet at point E. Okay. And it says angle D A B, this angle right here, is 46 degrees. I want to find the length of EB. That in green. Okay. So we got to find, your phones are away, correct? Your pencil is out. You should be writing this down. Okay, so we're looking at this triangle in the inside right here. So we have a right triangle, right? Because we know the diagonals of a rhombus meet at 90 degrees. So that's 90 degrees. So we're looking at A, B, E. We know A to B on the outside is 3. You with me so far? I'm just cutting this up. So I've got one triangle. All right. We know BAD is 46 degrees. So what's half of 46, guys? 23. So that's this right here. This is 23 degrees. And I'm looking for BD. So this part of my picture, I'm going to make sure I draw right on my paper. Okay? I'm going to make this a little bit, zoom out just a little bit. Okay, so here's my right triangle. AEB. I'm looking for X. This is 3. This is 23 degrees. Okay. So now, what is X? Is X the opposite, adjacent, or hypotenuse of this triangle? Opposite. What's 3? Hypotenuse. So which one am I going to use? If I've got TOA, I'm going to use sine. Sine of 23 equals opposite over hypotenuse. So I'm going to get 3 sine 23 equals X. And then we're going to put that in our calculator. So X equals what? Try plugging it in your calculator. I want to make sure you know how to do this. 1.17? And it doesn't give me units, so I'm just going to say units. Okay. I'm going to skip number 2 because I think you guys can do that one on your own. And I'm going to look at number 3. I think I'm going to do 3 and 5, and you guys will do 2 and 4 and show me before for points today, before you start working on your homework. Sound good? More points anyways, right? Okay. So let's look at 3. At a point from the base of a building, the angle of elevation to the bottom of the smokestack is 35 degrees. The angle of elevation, I want it to be like this. Hold on, sorry. Camera needs to be moved. Okay. At the point 200 feet from the base of the building, the angle of elevation to the bottom of a smokestack is 35 degrees. And the angle of elevation to the top is 53 degrees. Find the height of the smokestack. Okay, so first of all, I know I have at a point 200 feet from the base of the building. So if this is my building right here, that's my building. I'm 200 feet from the bottom of the building, right? So my 200 goes down here, 200 feet away. So far, so good? Okay, that's my building. All right, the angle of elevation to the bottom of a smokestack. So I know I've got a smokestack on the top of my building here. So I'm going to say that's my smokestack. My angle of elevation to the bottom of the smokestack is 35 degrees. And my angle of elevation to the top is 53 degrees. So this whole thing is 53 degrees. Find the height of the smokestack. So I want to know this. We're going to call it Y. All right, so you got 2 angles. So is anybody else like, what is going on, right? We've done this a bunch with 1 angle. Now you have 2. What we're going to do here is we're going to find the height of this whole thing, including the smokestack. We're going to find the height of the building, and then we're going to subtract. So let me talk about that again. We're going to find this whole height right here. Then we're going to find the height of just the building. I'm going to call it Z. And we're going to go X minus Z is going to give me Y, or is going to give me the height of my smokestack. Yeah? Your phones should not be out right now. I'm going to walk around and take them. If you want your parent to come pick it up, or your guardian, keep it out, because I'm not playing anymore. Put it away. Okay. All right. So let's find the whole thing first. So we're just going to look at 53. So 53 is the angle we're looking at. 200 is my what? Adjacent. And the whole thing, including the smokestack, is going to be my opposite. So I'm going to use what trig function? Tangent. So I'm going to say tan of 53 equals opposite over adjacent. So that's that x over 200. So I'm going to end up with 200 tan 53 equals x. So far, so good? And so x is going to equal 265.4 feet. Okay. Now I need to find just the building. So I'm not going to use 53 degrees this time. I'm going to use 35. Did anything else change? Is this still the adjacent and the opposite? Okay. So still tan of 35, I'm going to say of z, though, equals z over 200. So I'm going to get 200 tan 35 equals z. So z is going to equal, what do we get, guys? Somebody plug this in their calculator for me. 200 tan, 35. What do we get? 140.04. Okay, now I forget. How are we going to find what the height of the smokestack is? What do we do? We add them. We've got this whole thing. What are we going to do? Subtract. Okay. So 265.4 minus 140.04 gives me, what do I get? You got calculators right in front of you. How big is a smokestack, guys? Smokestack is 125.36 feet tall. Okay. It's a little weird because it has those double angles there, okay? But we know we're just subtracting here to find it. Number 4 is almost exactly the same. I'm going to have you guys do that in your own, but we're going to skip to number 5, and then I'm going to have you do 2 and 4 on your own. Okay, number 5. Are we ready, or do you guys need another second? We're good? Okay. Number 5, from the foot of the building, which is 150 meters from a tree, I have to look upwards at an angle of 22 degrees to the site of the top of the tree. From the top of the building, I have to look down at an angle of depression of 50 degrees to look at the top of the tree. All right. This is super weird, right? How tall is the tree? And then we have to find how tall is the building. Okay, so first of all, we know there's a building somewhere. All right. From the foot of the building, which is 150 feet from a tree. So here's my tree. Okay. It's 150 feet away. So I got that much. I have to look upwards at an angle of 22 degrees to sight the top of the tree. So for here, to sight the top of the tree, it's 22 degrees. I'm standing at the foot of the building. Okay? Why don't we just stop right there? Can I figure out the height of the tree now? Yeah. Okay. Let's do it. Let's make it x. This is, the tree is my opposite, adjacent, or hypotenuse. Opposite, 150 is my adjacent. So I'm going to use which trig function? Okay. Tan of 22 degrees equals opposite x over adjacent 150. So 150 tan 22 equals x. Was that too fast? Are we okay? So what's the height of the tree, guys? .6 meters, right? Height of tree. Okay, so I figured out part A. Now I have to read the rest of this. From the top of the building, I look down at an angle of depression of 50 degrees. So if I'm looking, look, so that's straight up the top, right? That's my angle of depression right there. If I'm looking down, that is 50 degrees. How tall is my building going to be? So I have a question. If the tree is 60.6 meters, and see this little part right here, I'll call it y. If I added y to it, would I get the height of my building? You don't get it? Let me draw this picture bigger. Okay. Here's my building. I love it when you guys give me good expressions so that I know if you're confused. Otherwise, I just assume you know what I'm talking about. Here. I've got my building. From the foot of a building, which is 150 feet from a tree. And here's my tree. So far, so good? Yeah? Okay. I have to look upwards at an angle of 22 degrees to see the top of the tree. I'm going to ignore that part right now because I already found that. From the top of the building, I have to look down at an angle of depression of 50. Now remember, with angle of depression, we think of like a tightrope walker, right? If I was to draw a rope straight out, okay? So I'm looking straight out, like, okay, so I'm up here, right? If I look straight above your head, Ashton, I'm looking right like that. Now I have to look down to see you. That's my angle of depression. Does that make sense? So like straight ahead, down is the angle of depression. So we draw that imaginary line. That's where that purple line came from. Yeah? Okay. So that's where this line is coming from. I'm looking down at it. So that's 50 degrees right here. Okay? But how does this help me with this building? Well, I know, see this distance right here that I just drew in blue? The building's that much taller than the tree. So if I could figure out what y is, what would I do to it to figure out the entire building? I know the height of the tree. Y is the distance from the top of the tree to the top of the building. So what do I do with those two things? The height of the tree and y, what do I do to them to find the whole building? Have them. That's the word I'm looking for. Okay. So we get, this is 150. Do we get this purple distance is still 150 at the top here? Okay. So this is my adjacent. This is my opposite. So far, so good? So I'm still going to use which trig function? Okay. So I'm going to say the tan of 50 equals the opposite y over the adjacent 150. So I say 150 tan 50 equals y. So I get y equals what? 178.8. Is that right? Yeah. But that's just the difference from the top of the tree to the building, right? How do I find the total height of the building? I take 178.8 and add it to 60.6. And that's how I get the building is 239.4 feet. Building height. Notice how I found two different things here? Do you see how I'm labeling them? That's really important to do on your quiz, so I don't think the tree's 239.4 feet and the building's 60 point, I mean, not feet, this is in meters, right? Meters. Okay, because I'm like, that's a really short building, that's a really tall tree, right? So make sure you get them right. All right, what I want you to do for the rest of the hour is, I want you to do number 2 and 4. Check them in with me first before you turn over and do the homework. You do get credit for this, for doing 2 and 4. So make sure you do them, check in the answers with me, and then you can do work.